Alright, this is lesson 2.9 in our calculus class. Unit 2 is on derivatives. Lesson 9 is on derivative of trig functions, round 2. Okay, so now that we know the quotient rule, we can use the quotient rule to find the derivatives of tangent, cosecant, secant, and cotangent. In lesson 7, we kind of touched on them briefly and showed you what they were, but now we're going to show you why they are the way they are, which is much more useful because knowing how to get the derivatives is much easier than memorizing the derivatives. So like I said, we're going to work using the quotient rule to find these derivatives. So make sure you know the quotient rule: low d high minus high d low over low squared. So the derivative of tangent is secant squared. If I take tangent and write it in terms of sine and cosine, then it's equal to sine over cosine. So the derivative of sine of tangent is equal to the derivative of sine over cosine. Well, we have a derivative of a quotient of functions, so we can apply the quotient rule. We need to know our top function we'll call f of x. And so the derivative, or f prime, if f is sine of x, then f prime would be cosine. The bottom function we'll call g. So if g is cosine, then g prime would be negative sine. So if we set this up with a quotient rule, we get the derivative of sine over cosine is equal to the bottom times the derivative of the top. So g in f prime minus the top times the derivative of the bottom. So f times g prime. And we see that we get cosine squared, and then two negatives make it a plus, so it's cosine squared plus sine squared. And it's all over the bottom squared, so cosine squared. Now, we know our Pythagorean identity is cosine squared plus sine squared. Well, that equals 1. So we could write this as 1 over cosine squared. And since cosine, or 1 over cosine is secant, it's a reciprocal function, then 1 over cosine squared would just be secant squared. So the derivative of tangent is secant squared. Alright, cosecant. Cosecant is the same thing as 1 over sine. So the derivative of cosecant with respect to x is equal to the derivative with respect to x of 1 over sine. So if 1 is our top function, f equals 1, f prime equals 0. Sine is our bottom function, so g is sine, g prime is cosine. And we use quotient rule, we get the bottom times the derivative of the top minus the top times the derivative of the bottom. So let's see here. So I got sloppy in my writing here. I didn't write sine of x times 0. So please know this is not sine of 0. This is sine of x times 0. So anything times 0 would just be a wash, just 0. We're left with negative 1 times cosine, or negative cosine. And the bottom is g squared, so sine squared. We have negative cosine over sine squared. If I break up the sine squared into a product of two fractions, then we have negative 1 over sine times cosine over sine. Well, 1 over sine is cosecant, and cosine over sine is cotangent. So our derivative of cosecant is negative cosecant cotangent. Now we're going to keep doing the same process here. Derivative of secant is secant tangent. Secant is 1 over cosine, so we use the quotient rule here, and we get sine over cosine squared. We break that into 1 over cosine times sine over cosine, and then 1 over cosine is secant, and sine over cosine is tangent. So here's the derivative of secant. Derivative cosine, or sorry, derivative the derivative of cotangent is the derivative of cosine over sine. So if we go low d high minus high d low over low squared, we end up with negative sine squared minus cosine squared over sine squared. So we factor out a negative 1 from the numerator. Then we find our sine squared plus cosine squared, our Pythagorean identity. We can replace that with 1, so we get negative 1 times 1, that's just negative 1. Negative 1 over sine squared would be 1 over sine is cosecant, so this would be negative cosecant squared. All right, so bottom line is, if you know how to take any trig function and put it in terms of sine and cosine, and you know the quotient rule, then you can rederive any of the trig functions. And it's also helpful to know that the derivative of sine is cosine, and the derivative of cosine is negative sine. It's also helpful to know too. If you know those three things, you can derive any of these functions.